Hey, welcome back to Harley Davidson Machine Shop, and I'm your host, Don Dyer, factory certified technician. Now, I'm going to explain lapping, and not just lapping the Harley Davidson crankcases with the proper tool, but I'm going to talk about lapping in general that will really be helpful in properly using this tool. And we'll start with flat lapping. And I've got a flat lap here. I'll stick this back in here because this round lap for holes is called a barrel lap. And you can buy barrel laps like from any of the industrial supplies in all kinds of sizes. But what makes this one special is it's guided. It's got the long pilot shaft on here, and it's got the adapter in the Timken bearing side, the dual Timken bearing like these earlier Harley Davidson engines had. Now, the K-Model was the first to have that in 1952, and they didn't do it for the big twins until 1955. Then they totally discontinued it in, I think, 2003 on the twin cams. And one of the things that they do for better performance or high performance engines is cut out what's there and install an adapter for 2003 and later engines to put the Timken bearing back in there. Now that bearing arrangement is the very same with the Timken bearing for hydrostatic transmissions like they have in big excavators and combines and heavy equipment. And those hydrostatic pumps are a lot similar to a Harley Davidson engine, except some of them actually have pistons. That's a different kind, but the hydrostatic ones they do have pistons, but they're in a rotating group and kind of a different deal. But and you do flat lapping on the valve plates and the piston shoes. The pistons are really quite small, and they're in something like a revolver cylinder, and that cylinder rotates, and they have a swash plate, and the pistons poke out, and when it comes around, they push in. I thought I'd mention a few things about that. Now, here's a flat lap, and it's a miniature one, kind of a cute one here. This is at the mold shop that went out of business. And I'll demonstrate how to flat lap, then we'll get into the barrel lap and what happens, okay? Now let's see if I can get this camera real close here. I hope you're all doing well. I've been very busy doing a variety of things and doing some research too on later model motorcycles, looking at some other people's videos. And there's some very good people out there making videos on Harley Davidson engines. And I can fill in some gaps from the industrial perspective. I haven't found anyone that works on Harleys on YouTube that has the industrial experience that I have. Now, this is what's recommended. You can hardly read it on that label here. It's Clover Grade C lapping compound. And it's about 220 grit. It's silicon carbide, and it breaks down. It's fairly coarse. Now I got this quite a bit of oil in the can here, and I believe that's probably sunning oil I got in here. So I'm going to take it and spread this around, spread this stuff around pretty good on the flat lap. And get it around on there. And I'll lap a spacer. I'm always making spacers. I used to for the motorcycles too. That a 4140 chrome steel, it doesn't rust too bad. You can make stuff out of stainless. But I like 4140 for machine work. That spacer's for stuff on the milling machine table. So I got this kind of spread around on there. And the proper thing to do now, let me get it on there real good. Now I learned to do this a long time ago. And in the hydraulics, we'll have machines with rotating platens like this. They rotate, then you can put your work in these holders. Quite a bit bigger than this. So this is a wet lap here. And I'll talk about wet versus dry. See, I got that smeared around on there with that oil. Okay, put the little stick back in there. Now I'm going to take a piece of metal that's just a piece of aluminum, and I'm going to roll that stuff into this cast iron. These laps are cast iron. The barrel laps are too, or they can be brass. Oh, I don't know about any other metals. Cast iron or brass, usually what they are, but cast iron's definitely better, or copper. Sometimes you use copper, particularly for diamond compounds. Now this is silicon carbide, and some of it will be aluminum oxide. But this is what they recommend for the Harley engine. So I've taken this and rolled that stuff in just with a scrap piece of aluminum here, okay? Now, we're going to start lapping, and I'm going to show you the proper way to do it. Now, I'm going to take and mark this. We'll lap... That's bevel. That's the bottom there. And I think you can see machine marks there. Okay, so I'm going to mark this on the top here. Put a mark on it. And I'll show you the proper way to hand lap something like this. So you want to, I'm going to put this over here so I don't knock it over. So you want to go in a figure-8 motion, and you want to go over the entire lap like this. See, I'm doing a figure-8 motion over the entire lap. That way it wears evenly. Okay, then you take and rotate it 90 degrees and keep doing it. Now, this lap is real wet, and it'll cut fast. Keep that figure-8 motion going over the entire lap. I think I'll even move the lap a little bit. It'll help. I think I'll cut a piece of wood and set this lap in so it'll be easier to handle. Very handy little thing. I'm going to rotate it again 90 degrees. See the mark? Figure-8 motion. I think I'll rotate the lap. I'll be more likely to get it even that way. But the important thing is to rotate that work 90 degrees frequently. I'll do it again. I don't know if you can hear it. It's definitely cutting. Get those corners there, huh? Yeah, it'll be easier if I inset that in a piece of wood. Okay, we're back where we started. Figure 8 motion. Now this lap's starting to dry out. It's starting to push that compound into those grooves. And that's what those grooves are for, is to catch this compound. And it feels a little smoother. Not quite as grabby as it was at first, because it is pushing that stuff into those pushing the compound into the grooves. Rotate that. Rotated the part 90 degrees. Now, see, the lap is continually drying out here. And the compound is breaking down and getting finer. We'll take a look at it in a minute here. Okay, that's where we started. Rotated it twice. Figure 8 motion. Try to get it over the entire lap. Okay, I'm going to take and wipe it off, and we'll have a look at it. Now, you got to be careful and not use the rag that you're wiping this compound out to wipe new bearing surfaces or something like that. Okay, you see, it's kind of it's turned that surface kind of a gray color. See that? Let's look at the other surface, see? Now that's what a lap surface starts looking like. And I don't know if you can see, but it's starting to take those machine marks out. There's still kind of a good circular, but it's taken out most of the record looking lines. As you know, I face this on a lathe and it makes those little lines like on a phonograph record. And it's removed almost all of those except one. An oily, dirty rag here with chips on it. See that? And if I keep going, lost my mark. If I keep going, it'll take that line out. Now, as this lap dries out, it starts not cutting as quickly. And it also is work hardening the surface. At the microscopic level, it's actually creating quite a bit of heat and hardening the surface. So in effect, I'm making a bearing surface and this is 4140 steel. It's got nickel and chrome in it. it'll make it tend to harden. You can harden 4140 by heat treating it. So what's happening also, get that as the lap dries out and pushes that compound into the grooves, it excuse me, it makes this flatter. Use my skin here to wipe that off. But you see that gray surface there? That's beautiful. And it's almost removed the deepest line. So when the lap is wet, it cuts faster. But it piles up on the edges and kind of rolls the edges. But as the lap dries out and you're finishing it, it quits doing that and makes this surface flat. You can see that gray appearance from the way it was. Still got a bit of a line there. So I won't have to go very much further. I'll stop doing this and we'll get on to the other one here, the barrel lap. So when you put I could put more compound on here, or just take and rub my fingers on that and lift that compound out of those grooves. But the compound that's staying on top here is breaking down and into finer grit. Keep rotating that. So the lap's drying out, and that's when it makes things flat, because the compound quits piling up on the edges and rounding those edges over. Now, I have a bit of a bevel on here, but if it wasn't, it'd get sharp and actually cut you. That's how flat that this can get. Get that off there. See that nice gray appearance there? And that surface is harder than this other surface. It'll be less apt to scratch. Okay? So that's what we're looking for when we're lapping, is that gray appearance, and letting the lap dry out when you're finishing to get the surface flat and not rolled over on the edge. Okay, so we get to the barrel lap here, and I'll get the camera set up at a different angle for that. Okay, I will be back in a minute here. I think. Okay, here we are at the K-Model bearing here, the right-hand bearing. Now, the rollers are straight rollers. They come in steps of oversize of 2 10,000ths in steps, from nominal, which probably 3/16 or smaller, to 1/1000 oversize, and then they have a repair roller that would be 2/1000 oversize. Now, lapping this takes very little material, and you can hook an electric drill or an air-powered drill to the lapping tool and run it that way if you have to remove quite a bit. But we'll take a quick look at this bearing here with this dial bore gauge. The glass fell out of this thing. So it's reading 2/10,000ths over 0 there, and we'll move it back and get it in a spot there. So it zeroes out towards the back there, and it appears to be tapered. Well, look at that. It's 1/10,000ths past 0 there. You rock it until it goes in the positive, and as you rock it, where it goes to the negative, I'm moving it back as the size. See, it's getting tighter there. So this bearing race is actually tapered 2/10,000ths. And you can check out around this too. It doesn't look very much out around, but it's tapered towards the front. Let me stick this in a place where it won't get knocked down. That's a standard Poughkeepsie dial bore gauge. Now I'm gonna charge the lap here, and I'm gonna dig into that stuff, and I'm gonna spread it around on this, just like I did on the flat lap. I think you can see me doing it. And this thing's a bit under adjustment. Okay, now I'm going to take my finger and kind of smear that around pretty good. Okay, to do it properly, you should take a piece of metal and roll it in. Push that compound into that cast iron lap. It's called charging the lap. So we're charging the lap, and it will be considered a wet lap at first, okay? And like I was talking about, how the flat lap will roll the edges on the flat piece of metal. What happens here is the bearing race will get bell-mouthed. So I'm going to push it through. First, I'm going to grab this oil can. And let me get a little oil on this lap here. On the pilot part anyway. There we go. Add some oil on this. This goes through that bearing guide. So to reduce wear, put a little oil on it, insert it through. It's held in the guide in the other side. Okay, it needs to be tightened up. Get that out of the way. And I've got this adjusting tool here. So as it goes this way, it expands. So I'll loosen the lock nut. There's kind of a hook spanner to do this, and this is a different kind of spanner, but it works pretty good. I'll give it about that much. Okay, snug that down and see where it is. Needs to be a little tighter. This is a little bit time consuming, but it makes a big difference. It trues the bearings up. And not everybody does this. Well, one reason that it's pretty expensive. So when you're lapping, you want to move it back and forth like you're honing, and it needs to be tighter. And we'll get it tighter. Loosen that. Move this another 1/8 turn or so. Then tighten the lock. And there's a taper on this shank here, and as it's pushing that way, it's expanding this cast iron head. We're getting close. Even more. I'll give it a bold turn here. Loosen. And back this one out. Expand that lap. Okay. See how it's doing. Yeah, it's not, now it's starting to grab. Okay. See if I can just do it that way. Yeah. Okay. Now we're starting to get a lot more friction on it. Moving it in and out. And it's forcing that compound into the lap and into those grooves. Continuing to tighten the lap. Now, the lap itself trues. Now we're getting some good friction on that. I can feel that little bit of taper. That's 200 millionths taper. It's not very much. It tapered a little bit more at the front. I can move that one a little bit. Yeah. Yeah, that's starting to grab pretty good. Moving it in and out like you're honing. And I'm feeling it getting quite smooth. Okay, it's cutting. It's actually cutting that race. We'll keep expanding it. There we go. And the lap is starting to dry out. Not quite as wet. We'll see if we can get that 2/10,000ths out of the 2/10,000ths taper right at the opening here. Okay. You get quite a bit of friction going there, and then it eases up, and you know, to expand it a little bit. That's feeling good. Here it's starting to squeak. It's starting to get dry. Okay, I'm going to adjust it again and run it, and then we'll check it. Check it again with the gauge. There we go. Okay. Now, when it squeaks, I just took and dipped my little finger in that oil, and I'm just going to put a drop on there. Feeling really good. Come on. Hear my stool squeaking here. Like I say, you can run this with a drill, but you don't want it to go faster than 200 RPM. You want to keep it real slow and work it back and forth like you're honing. Whoop, there we go. Okay, let's check it out here. Set it over here. Got a little rag here with some solvent on it. Like I say, you want to watch these rags. Now, I don't know if you can see in there, but it's starting to get that gray color. Okay. Get the dial bore gauge in there. Okay, right at the opening, I've taken out just about that 2/10,000ths. Let's move it back in there. It's still got a little over 2/10,000ths taper. Well, way out. Let it get through that. Oh, that's looking better than I thought. There's two oil grooves in here, which is really, get them on the other side of that oil groove. And it's not, there we are. Okay, that's 1/10.5 on the plus side. Let me push it back, find the back oil groove. Okay, we got it within 1/10,000ths anyway. Okay, let's continue a little bit here. And if you press a new race on, it'll feel lumpy with the lap because it distorts. Now, a lot of people will do this with the sun and honing machine, but there's no guarantee that it'll be in line with the bearing in the left-hand case. So we'll tighten this up a little bit. Just like that. Get that back in there. How are we doing time-wise? This takes time. Nice and smooth now, nice and snug. The lap's not squeaking. Okay, going for a crosshatch finish too. Now a crosshatch finish will retain a little bit of oil, and it'll get the help get the rollers, the new rollers that you install. Okay, I'm going to tighten it one more time and we'll check it. So these gauges I use are a standard brand, standard made in Poughkeepsie, New York. And I think they still are made by Federal. And Sonnen makes them, very expensive, got a little bit of a squeak there. It's actually starting to cut pretty good here. As I keep adjusting it out. Okay. Am I plugged in there? Come on, there we are. Yeah, it's getting pretty snug there. That race is getting really round. I had it really basically easy. Now I'm going to just ease it in now. Get it kind of a tight spot there. You want it to feel about the same all the way through. Now I'm going to try to get this. Okay, I'm finding the tight spots and working on them. It's starting to feel pretty good. I'll take and check it here real quick. I can see this has got a ways to go, but I wanted to give you an idea of how this works. Okay, I got it right at the opening, about 1/10 and a half, 2/10. We'll move it towards the back, and it's going to take a while to straighten this up. Oh, that's pretty good. I got it within 1/10. It's running about 3/10 at the back. Get it up very close here. There's a couple of oil grooves in this race here. That's kind of unusual. I'm reading 3/10 there. And 3.5, 4/10 towards the back. It gets in that groove and it gives you a false reading. Yeah. Looking at 3/10 and just about 4/10 at the back. So if I keep going on this, it will totally even out. And the way it's looking here is it's gonna clean up real well. And when I get to the point of fitting the bearings in here, I will continue with the lapping. Now I just wanted to point out how this works. I'm going to put a little bit of oil on there. And run this thing through. Oh, it's getting too tight for that. Okay. I'll get that run all the way through. I might have to back it off a little bit. Yeah, I have to back this up. Get the thing seized in there. Okay, back it out. Now to make it smaller, I loosen the walk here and turn this a little bit. Should be able to get back to, I'm gonna knock that down. That's feeling good. Quite a bit more even than it was before. So we're getting it close to true. Okay. Okay, it's a ways from being perfect. It's a little over 3/10 at the opening. About 4. And about 5. So I got it 1/10 better. This is really a difficult bushing because of the oil grooves. I can tell you that other ones don't have that. And about 5 there. Yeah, I'm getting it very straight. I've taken a good 2 or 3 tenths out of this so far. We'll have a look at the bushing. Okay. You see the finish is kind of dull, but it's got more to go to straighten it up. There's plenty of meat on this bushing, and it's going to clean up. It got the alignment good. If the alignment was real bad, it would just like you just see one spot. So it's looking pretty good. Let's get the light inside. You see that? It's pretty even, but it's got a ways to go to be perfect. Yeah. Hey, I hope that was somewhat of an explanation on how to do this, and I'll continue with it as I can. Okay, thanks for tuning in on this. I got something else coming up too here, so I'll be back. Okay, just a quick recap here on things. Now, when I was doing the flat lapping, it took that shiny surface, and after it was lapped, it made it that gray color. Now the races will be a shiny surface, and you can see it starting to gray out. It'll take a bit longer lapping, longer than this video needs to be. And I think I've pretty much explained the wet lap will cut fast, but as the lap dries out, and you have to, with the barrel lap, you have to make it tighter to keep fitting, it straightens the hole out. So I got the hole pretty straight, but I'll continue doing it at the time that I get the shafts and everything needed and the bearings lined up for it. But I think you can see it's got it's starting to get that gray surface all around, and that means that the case work I did is good. It's all going to be good. It's going to line up just fine. So I also want to say I really appreciate the donations. That's very nice, and thanks everyone for donating. And I will keep going. I've got a lot of things happening. I'm looking for a spot where I can work on motorcycles, and it has to be out of Washington here. Because the business climate and the restrictions, there's just a whole bunch of restrictions, and there's a bunch of nasty things going on with businesses here. Businesses are taken off out of this state, and it's just a bad business climate in the state of Washington. It's okay to be retired here. I definitely get a break on the property taxes, but everything else is expensive. Gasoline, food, everything, and it's not going to get better in this state. And Harley Davidson's, I can tell you in this town here, there's virtually nobody that works on something as old as a twin cam, any of the businesses here. And it's just dead. People hardly ride motorcycles around town here. It's not a friendly state, or especially this town of Walla Walla. It's not friendly towards Harley Davidsons anyway. They have this stigma. But I'm going to keep going, and I'm looking for a building and a suitable place, and I think that'll happen. So thanks again for the donations, and I'll be back with some interesting crankshaft tips. Okay, thanks.